Good afternoon. It's Saturday afternoon where I am, and I've got a couple of hours to get started on something I've been thinking about for a little while. What I wanted to do was a bit of a rundown on some of the equipment, some of the technology that we've seen in use in this Ukraine war. So I kind of titled it, when my working title for it is From the Ground on Up. And I'm going to start just going through some of the equipment that we've got. Now, this is going to come out in about 3 or 4 parts, I expect. I don't want it to be one long 4-hour thing. So I'll probably try and get it done over the next couple of weeks. But this first one, I'm going to talk through, probably work from the ground on up. So start by covering off things like mines, some of the mines that are used in the conflict, and then moving on to mine laying equipment, grenades, grenade launchers, that sort of stuff. And then start to follow that up with mortars, artillery equipment, air defense, drones, and ending up with aircraft that are involved in the conflict. So that's the sort of thing. If this is something you might be into, stick around. If not, I'll be back later today or tomorrow with the normal daily battlefield and sort of geopolitical update that I do. There's definitely a lot of interesting stuff happening today that I can talk about there later on. But for this thing, this hardware review, pardon me. So this isn't going to be thoroughly exhaustive. I'm not going to cover off everything. You know, if I did that, I could probably spend all day just talking about landmines. There's so many different ones in use. But along the way, as I've been doing these reports, I've seen bits and pieces of equipment that I've just thought of, wow, really interesting. Had no idea they worked that way, or that sort of technology existed. And so I hope some others will find this interesting too. I guess we'll get started here. So, starting off with some landmines. Let me just get the screen up here. Anti-personnel, anti-infantry mines. So these are the ones which I imagine must just be the infantryman's nightmare. This must keep you on edge all the time, particularly when you're walking through any sort of forested area where you really struggle to see what's ahead of you and what's hidden. So what I've got on the screen here is a bit of a mix of either the American M18, the Claymore mine, or the Russian MON-50. They're very similar in design. Directional anti-personnel mines. The MON-50. So the MON-50 contains 700 grams of RDX, which is an explosive material. RDX is the abbreviation for Research Department Explosive, or hexagen. It's an organic compound with the formula O2N2CH23. It is a white, colourless and odourless material used as an explosive. Now, the mine contains 700 grams of that, and that is used to propel approximately 540 or 485 fragments of metal. Now, these can vary, either in different variants. They can be steel balls for the 540 steel balls, or short steel rods. In either case, you don't want to be anywhere near one of these when they go off. That explosive then propels those fragments to a lethal range of about 50 metres and a spread of about 45 metres on about a 54-degree arc. So, 90 degrees, quarter of a circle, 45 degrees, eighth of a circle, a bit bigger than that. About 54 degrees, I think, for the MON-50, and about 60 degrees for the Claymore. That distance, that 50 metres, that is about half the length of an American gridiron field, or a little bit more than the width of a gridiron field, for those of you in America who are watching. For those of you in Europe, about half the length of a soccer pitch, I think, too. They're normally about 90 metres. So this is 45 to 50 metres range that these anti-personnel mines work on. The claymore is also known as a clacker, and the reason for this is that in a manual firing mode where you are choosing to fire it under command, there is a firing device which needs to be squeezed 3 times to initiate detonation, and that has that clacking sound. The claymore is known for what's written on the front, which you may be able to see up there on that top image, which is front toward enemy. And as I said, these are a anti-personnel. They are a defensive mine. So you would set them up around the perimeter of your base in a defensive mode. They're going to explode out towards the enemy, the approaching enemy. And you, in your base, should be relatively safe from fragments of these mines when they go off. Okay, next in line here is the POM-2. So the POM-2, or the Protopopechtotnia Oskolachnia Mina, which literally means the infantry fragmentation mine number 2. This is a scatterable Soviet-era self-liquidating fragmentation anti-personnel mine. So this one works differently. This one doesn't contain fragments that are sent out to, exploded out like ball bearings in the claymore. Instead, the shell of this, as it explodes, the shell fragments, and that explodes in a circle around this mine. It's considered a self-liquidating mine, which means that it has a self-destruction capability. Now, that is generally achieved by the use of a battery, and basically, I think in simplest terms, once the mine has been armed, as part of the arming process, that battery becomes engaged, and then when that battery runs out of power, that causes a trigger within the mine for it to self-destruct. So you might find, depending on the temperature, because that will have an impact on the battery's life, that these might last, from some of them are from 1 hour to 40 hours, depending on the mine. So that's a self-liquidating. I think there are some other self-liquidating mines who actually have a chemical timer in them. So again, once the mine becomes armed, a chemical timer begins, like a slow fuse. And eventually, once it burns through to the end of the chemical available, that triggers the mine to self-destruct. So the POM-2 operates by, once it has been deployed, 4 wires are ejected out at 90 degrees north, south, east, west from the mine. And they are shot out a distance of 10 meters or about 30 feet. And a few pounds of tension on any one of those wires will cause this to detonate. And it contains about 140 grams of TNT inside of it, and just fragments the casing, and that's what does the damage. So, it does. You could imagine the way that these work. They're laid out somewhere, either on a field or in a grassed area or wherever it may be. The idea being that one of those little wires, somebody walks past, it gets hooked on their boot, and that's enough for it to pull. And if you're within range, you're within that 10 meters of that length of wire, and you're in the lethal range of this device. Okay, now these nasty pieces of kit. The PFM-1 anti-infantry high explosive mine. So these are of Soviet and Russian production. It's a scatterable high explosive anti-personnel landmine. They were used in Afghanistan, which is where they got a nickname. Their nickname is, they've got one nickname being the butterfly, which you can understand why, purely from the shape of them. They've also got a nickname of the green parrot, and this reportedly comes from when they were deployed in Afghanistan at that time. The colours that were available were this green colour, and against the sandy, dry terrain in Afghanistan, the green really stood out, hence the green parrot name. These can be deployed from mortars, helicopters, and even aeroplanes, and in large numbers. They will glide to the ground without exploding. They have two wings on them, on the PFM1. They spin as it drops. It spins, and those wings then stabilize its fall, allowing it to land quite softly. Its descent is retarded by the wings. Of the two wings, there is a thicker one. The thick wing contains a liquid explosive, and the overall size of this, it's about 120 millimeters. So that's 12 centimeters, about 4 inches, 4 and a bit inches, I guess. Maybe a bit less. The plastic body of these is produced in a variety of colours, and the Cyrillic Y that you can see stamped out of the one in that main picture there indicates that it is a training round, not a live round. So here in this other picture here, this will be a live one. It doesn't have the Y stamped out of it. Yeah, and here's one of them, which is in the brown colour. Now, any pressure in excess of 5 kilograms will activate the mine. So even reportedly holding these between a thumb and forefinger can deliver enough pressure to them to cause them to explode. And while they are marketed as the charge being non-lethal, they do maim. And one of the big problems with these is the fact that they are so small, they blend in with the grass so well, and people, and particularly children who are unfamiliar with what they are likely to pick them up and play with them and then suffer, if not death, serious, lifelong damage. So here's a cassette of them used in when they deployed, from a mortar or something like that. These can't be laid manually, must be laid using mine-laying systems. So things like a remote UMZ mining equipment, which I'll get to later in this video, PKM mortar systems, even on MLRS, multiple launch rocket systems, they can be fired from there, and helicopters using a VSM-1 mine-laying system, which I'll get to. So when they're stored, they have a pin restraining a detonating plunger, and once that arming pin is removed, the plunger is slowly forced forward by a spring until it contacts the detonator, at which point it is armed. So then it's a plastic outer skin. Deformation of the soft plastic skin forces the arming plunger to strike the detonator, and that detonates the mine. So it releases it, it forces it to strike, and that causes it. So effectively, the whole body of the mine is a pressure primer. Some of the challenges with these is that they are plastic, they are lightweight, they can be carried by water and snow, so they can end up in areas that are unexpected. There are two variants. There's a PFM1 and the PFM1S. The S is one which does have a self-liquidation mechanism, and this activates again within 1 to 40 hours depending on the weather conditions. With these, I was unable to find out if these actually, their self-liquidation is managed by a battery or a chemical process. But even this self-liquidation technique, which is there to reduce the amount of harm to civilians and unexpected people in the future by detonating after a period of time, even that can be a challenge where people may be in the area where these mines have been laid and it's within that 40-hour window, and they just, without even stepping on one, they go off next to you, and they just self-liquidate next to you, and that causes damage to people. Okay, so we're just going to move on then to into the realm of anti-tank mines. So these, you will probably have seen plenty of these in footage of the special military operation. These are the Soviet era, the TM62. They are an anti-tank blast mine. These can be laid manually, or automatically from mine laying equipment. Pardon me, things like the PMR1 and PMR2 wheeled mine layers, the GMZ3 tracked mine laying vehicle, and the VMR2 helicopter mine laying system. And I'll get into these systems in a little bit. Now, the Claymore we spoke about at the start had 700 grams of explosive. This has 7.5 kilograms of explosive, so 10 times the amount of explosive compared to the Claymore. There are variants of the M72 and the M80, which have vibration-based and magnetic influence fuses. So the magnetic influence fuses work with the steel body of a tank driving over the top of one of these mines without actually having to depress it. So the track itself doesn't have to depress it. It just has to have metal pass over it within a range where that magnetic influence fuse will then trigger the mine. Now, these mines can penetrate armour to a depth of 100 millimetres, which is 3.9 inches, or as I had to check with my father, who's more old school than I am, that's about 3 inches and 15/16 for those of you in that era. I kind of just escaped that era. Some of these TM62 mines also come without a metal casing, come with a cardboard or a wooden casing. And this is to make them more difficult to detect. So if you are attempting to detect them via the use of a magnetic metal detector, like you might go metal detecting to find metal in the ground at the beach, that sort of thing, something like that, which is attempting to detect these that way, far less likely to detect them if they have the cardboard or wooden casing. Now, the PTM3 mine. So the PTM3 is a shaped charge anti-tank mine. Now, they are only about 33 centimetres long, so a little bit more than a foot long. They will self-destruct 16 to 24 hours after deployment, and that self-liquidation function is managed by a battery. So again, that battery gets turned on once it runs out. That's it. It self-destroys. There's some interesting notes on the self-destruction of these mines. If it isn't self-destructed, then it should be destroyed using a remotely triggered explosive charge weighing 0.2 to 0.4 kilograms placed next to the mine. So this is the SOP to describe how you would do this. It is reportedly, it's prohibited to destroy the PTM3 mines before the self-liquidation period has elapsed, as simply then placing the explosive charge next to the mine could trigger the mine. And this line here I find is interesting. For whatever reason, it's kind of made me smile. If the mine must absolutely be removed before the self-liquidation period has elapsed, it can be destroyed by machine gun fire, preferably mounted on an armoured vehicle at distance. Which makes sense, I suppose, if you're destroying a mine. The Palm 1. Now, this is an unusual looking mine. So the Palm 1, and there are variants of these, the Palm 2, is a German manufactured off-route mine. So these fire a small fin stabilized rocket. As you can see, looking at it here, it's something a single man can carry. It has this pointed nose on it for firing that rocket out. They operate with a fiber optic trigger cable. So a fiber optic, which is a glass fiber cable, is laid out in front of the mine. So I imagine these may well be set up, where there's a roadway, you're expecting tanks or armour to come through there. You would then lay out your optic fiber mine in front of this, optic fiber trigger cable out in front, over the road, and then as the vehicle crosses it, it crushes the optic fiber cable, and that causes it to detonate and fire the rocket. The Palm in the name, PARM, stands for Panzer Aber Richtmine, anti-tank directional mine. 1,600 of these DM52, which are the Palm 2 variant, mines were delivered to Ukraine armed services in early May 2022. It is manually placed. These aren't placed by helicopters or things like that. You manually position them, much like this man here appears to be doing. And incorporates an arming delay of 5 minutes. It can be detonated either by command or a fibre optic cable, as I've described. The Palm 1 has an effective range of between 2 and 40 metres, or 7 and 131 feet. So yeah, I get the impression that these are generally sort of positioned alongside roadways, might be the most likely place where you're pretty sure that a tank is going to come through. The rocket that is fired has a velocity of approximately 120 metres per second, 390 feet per second, or 270 miles per hour. And it has a claimed armour penetration of 600 millimetres, or 24 inches. So that's significant. The TM62 anti-tank mine, I think that was 100 millimetres of armour penetration. This one's 600 millimetres. The Palm 2, or the DM22, of which those 1,600 were donated to Ukraine, they have an upgraded range of a maximum range of 100 metres and 30 inches of penetration. Now, this next mine that we're going to talk about was one that really, for whatever reason, caught my attention, and hopefully I've got a little bit of video I can just show of this in a moment. But let's just have a look at these here. Looking like something out of Star Wars. The PTKM 1R Top a Tank anti-tank mine. Now, this is some advanced mine technology. I do have a video, I think. Let's just see if it'll play without an ad. If it does. So we've just seen there a projectile being thrown into the air and then a strike coming down. Here you can see that projectile being highlighted and the way that it sends a shaped charge down to the target, the tank beneath it. So the way that these work, they're capable of selecting what passing vehicle they want to attack. The way that they do this is that they have sound, they have microphones and vibrational detectors on them, and an internal database. So when a vehicle goes within range of them, they have a range of about 50 meters. So when a vehicle goes within that 50-meter range of this tank, so you don't have to drive over this. This can be set off to the side of a road or somewhere hidden behind a bush. But within 50 meters, through its feet, it's able to detect the vibration caused by different vehicles. Now, obviously, a civilian car is going to be different to a bus, is going to be different to a 70-ton tank. They also have microphones on them, and again, an internal database where they are able to compare the sound they hear. Hey, is that a small 4-cylinder engine, or is that a big V10 or V12 diesel engine, or whatever it is that or maybe even the sound of an Abrams with their with their turbine engine in them. Is that the sound we're after? If it is, this little guy then determines that it's found a target. It then, let me just show this image here. It then pops a projectile into the air. That projectile then uses infrared and radar sensors to locate the target within its range. And once it is within range, it then detonates a shaped charge. So that's the shaped charge is usually a casing of something. It can be like copper and a bit of a cavity. An explosion happens which forces that copper casing down into a liquid jet of metal, and that then fires down with a massive kinetic energy, pierces the tank, or if it doesn't pierce the tank, I imagine it hits with such force that it's able to cause what I think the correct term is pelling pelling with inside the tank. So pelling with inside the tank is where something strikes the outside. It doesn't break through, but the concussive force of it hitting the metal causes fragments of metal on the inside of the vehicle to erupt off the side. And so you effectively get a fragmentation effect inside of the vehicle. They come with two parts to the package: a transporter, launcher component, and then the combat element, which is this explosive device. So once the target comes within 50-meter radius from the mine, the seismic sensor commands to launch the combat element. The combat element then follows a ballistic trajectory, and its sensors, both thermal and radar, scan the Earth's surface, and when the sensors detect the target, the warhead is detonated and strikes the target from above. So again, one of the key benefits of these is not only the fact that they can be taken off route. Not only that, but they're not going to waste themselves on a civilian car. They can detect and determine what they should be attacking, but they're able to attack from the top, which in tanks is generally their weakest spot. Underneath, they're prepared for ground-based mine, like things like we saw before, the TM62 that you might drive over. On the sides, they've got protection against things like the Palm 1, which is going to fire that rocket. But from the top, they're generally not very heavily protected, and that's the weakness which these try to exploit. Okay, so just moving on from mines, now let's go to mine laying. So the VSM1. Now I think I've got a video here too, which hopefully will play for us. Let me just get that a little bit bigger. So here we can see a helicopter, little puffs of smoke coming up behind as it is projecting downwards mines onto the battlefield. So I'll just jump back here. Okay. So this is the VSM1 mine laying technique. It is a Soviet helicopter-based remote mining system. Now, this is something which has been mentioned a number of times, not necessarily the helicopter version, but this remote mining capability, which I think has been critical in Russia's success in defending against Ukraine's heavy armor in areas like Robotny, where Ukrainians have been able to perhaps move forward, demine an area, be able to move forward, and then, whether they're aware of it or not, the Russians over the top of them remine their escape route. So when they turn to leave, what they thought was a demined area has again become a mined area. The VSM1 is a Soviet helicopter-based remote mining system. It can be mounted on various variants of the Mi-8 helicopter, the Mi-8T and the Mi-8MT, and it can deploy a range of fragmentation and high explosive mines. They can spray, depending on configuration, anywhere from 116 to 8,352 mines in under a minute. So I guess if they are deploying the bigger, heavier anti-tank mines, we're talking the 116. And if we're talking about those petal, these nasty little guys here, this sort of thing, then maybe we're talking the 8,000 of them in a minute. So what this means is that this technique can create minefields with a density ranging from one mine every 5 to 6 square meters to several mines per meter, depending on how high up, how elevated the helicopter is at the time that it is performing the mining. It's reported that generally the helicopter crews perform the mining from an altitude of 30 to 150 meters at speeds of 150 to 220 kilometers per hour. And depending on the type of mines loaded into the system, this means that the VSM-1 can mine areas of up to between 400 meters and 2,000 meters, or 2 kilometers in length, and a width of 15 to 60 meters. So if you're doing, you do a couple of runs where you do a 15-meter minefield that's 2 kilometers long, you can be mining a front line of 10 kilometers pretty quickly. It's a couple of minutes it seems like it would take you to get through that. It might take a couple of runs or a few helicopters, I'm guessing, but still, in terms of being able to lay mines quickly and densely, it seems like it's an effective system. All right, now the UMZ, we talked about this before, mine laying system. This system's called the Clash. So this is a tracked mine laying vehicle based on the chassis of a T-72 or a T-90 main battle tank. As you can see, it has these barrels, these banks of barrels within them, and these are capable of then firing out mines. It's the UMzG Clash is a Russian-made multi-purpose tracked mine-laying vehicle, motorized with a diesel engine, develops 840 horsepower. It has a maximum road speed of 60 kilometers per hour, and for its own self-protection, it carries a 12.7 millimeter anti-aircraft cord machine gun. It also has some smoke grenade discharges to give it some ability to sort of disguise and protect itself and try and get out of the way if it needs to. It is designed to remotely deploy anti-personnel and anti-tank or mixed minefields from cluster dispenser units, which are those units on the back of it we can see there. Not only that, it can record the minefield coordinates and has the possibility, depending on the mines being laid, of setting the mine's self-destruction time from a mining control unit. So, again, for me, this was like, I had never really looked much into mines, but the ability to now be able to lay your mines, record where you had laid them, record what types you have laid, and ideally set their self-destruction time on them so as to try to avoid the possibility of causing death and harm in the future to civilians, non-combatants, or after the war has completed, if you have mines just laying around that are unexploded. There is a UMzK variant, which I believe is this guy here, which is a truck chassis instead of the T-72 or T-90 chassis. It's not tracked. They can carry up to 180 clusters. The types of mines are anti-personnel, PFM and POM, anti-paratrooper or anti-tank mines. These have the ability to create anti-personnel minefields of a length of up to 3,200 meters or 3.2 kilometers. That's a PFM. Using the POM anti-personnel mines about 5,000 meters, 5 kilometers, and anti-tank mines, the PTMs, at a minefield length of 600 meters. The minefields it creates are 15 meters. Between 15 meters and 240 meters wide, and the mine laying speed is up to 40 kilometers per hour. So again, not as quick as the helicopters to get them laid, but if getting them laid in a hurry isn't your major concern, then these give you some good ability to. One of them can do 5 kilometer long stretch of mines. Really quite amazing and quite frightening to think that you might be, as I've said, in an area you think you've progressed securely through the minefields. Maybe it's time to head back or go somewhere else where you think might be safe, only to find that it's been remined by something like this from a distance. Now, the next one is the ISDM, the Zemlederye mine laying system. So this is an advanced system. It's on an 8x8 CAM AZ military truck platform. Here we can see one in action. This is the type of thing we're talking about. with all these banks of like rocket tubes on the back of the truck. I'll just read a little bit about these. The 122mm tube launchers, which are mounted on the KAMAZ 6560 military truck. The vehicle is outfitted with 2 pods, and each pod contains 25 mine launcher tubes. These tubes are arranged in a single rectangular bank with 5 layers of 5 tubes each. The launch vehicle accommodates 50 rockets, each of the 122mm caliber, and loaded with scatterable anti-personnel or anti-tank mines. This enables the ISDM to rapidly mine an area equivalent to several football fields. The system boasts a firing range of 5 to 15 kilometres using these 122mm caliber missiles. So you have a range that you can disperse these over of the size of several football fields, and you can choose to do that at anywhere from 5 to 15 kilometres away from you. So if you've got a number of these trucks sitting here, you can mine at a distance with these. For its own defence, the truck is fitted with some smoke grenade launchers. It is also, and this is interesting, gets into some of the the advanced technology of these. The launch truck of the ISDM is outfitted with satellite navigation, a computer, and a weather station. These allow operators to fine-tune their parameters and consider the impact of weather conditions on missile trajectories. A distinctive feature of the ISDM is its intelligent programming capability. It enables operators to customize the mines to target specific entities, such as armored vehicles or personnel, thereby greatly minimizing civilian casualties. Furthermore, the system integrates advanced sensors that identify friendly forces, efficiently avoiding unintended engagement with allied vehicles. Now, this is something I didn't get detail on, but sounds very interesting to me, and I wonder if that has something to do with perhaps, again, microphone or vibrational sensors deployed with some of the mines or as part of some of the mines, where they are able to say, okay, I can hear a tank coming, but I can actually tell that this is a T-72 or a T-90, or hang on, that's a Leopard, or that's a Challenger, or that's an Abrams. I don't know. I'm just guessing here what that functionality might be. The system's remote-controlled mine layer automatically sets the launch missions and self-destruction parameters for the mines and generates a map of the mined area post-deployment. All this data is relayed to higher command levels. In line with the second protocol of the Geneva Convention, each mine is equipped with programmable self-destructors. This ensures that the minefields are not permanent, but are deactivated after a set period without requiring human intervention. Now, one thing that's interesting is that on a number of these mines that I've seen, when I've read through their self-liquidation or self-destruction timeframes, it's in the range of 1 to 40 hours, so for a couple of days. So I do wonder if some of these more advanced systems have longer periods of time that they can be activated to wait before they self-destruct, because it seems like a pretty intensive operation to go and mine an area and then a day later to have to go and mine it again, because all of those mines that you put down self-destructed within a 24 or 40-hour period. Again, I'm not a specialist in mines, but I do wonder now if these more advanced ones, if you might be able to set mines to wait until they receive a signal or then destruct themselves after a longer period, maybe a week, so that you don't have to be going backwards and forwards. Also, I imagine that very shortly there will be, you will have heard of IoT and the Internet of Things, that many of these mines will come out with small electronics in them now, which will make them Wi-Fi capable. So you would be able to send them out and sit there, and then over a distance, tell them to all explode at once, or tell individual ones to explode. And they could sit there for much longer periods of time, I would imagine, anyhow. Okay. Just going to move on. If you're still here, if it's still your afternoon, I hope you're enjoying it. Or if it's your morning or your evening or your night, I hope you're enjoying it. I'd love feedback on this. And if this is like, oh my God, this is the most boring thing I've ever watched, I turned it off after 20 seconds. Or if someone's actually made it this far and found it somewhat interesting. I found it interesting reading all this stuff. There must be some people who do. Anyhow, hand grenades. Hand grenades. Now, these things, hand grenades, I think, they're iconic. Every World War II movie has got someone biting the pin out of one and tossing it into either a German mine position or vice versa, the Germans throwing one at the Americans, something like that. I did see a video the other day of a journalist being given a mine in a trial testing centre and pulled out the pin and threw it, instead of throwing it through the gap where it would have gone safely to land, threw it, hit the wall barricade, it bounced back, everyone ran. Anyhow, these are a staple of, I guess, trench warfare or hand-to-hand combat, or even once you start to fight within residential areas. Some of the footage that's coming out of Ukraine of floor-to-floor operations going up the stairwell shafts of apartment blocks and room-to-room fighting and using grenades. Now, the one here on the screen is a GD5. These have been designed in the 1950s by the Russians. They've been in use since 1954. I think they were originally designed after a French F1 type of, I think were they modelled after these? Oh no, this is a more traditional one. Sorry, Soviet F1 is designed after the French F1. The F1 has got 60 grams of TNT inside it. The standard time delay for the fuse on one of these grenades is about 3.5 to 4 seconds. Now, you must have to do quite a bit of training with hand grenades to be effective in using them. Otherwise, I can imagine people just pull the pin. If they're close, the tension's really up. They pull the pin, they throw them, it lands there within half a second. Your enemy combatant now has a good 3 seconds to do something. Get up and run, throw a sandbag on it, chance at picking it up and throwing it back at you. I don't know, maybe not, but whereas if you had practiced it a few times and you're like, okay, I can see how far away they are, I'm actually going to pull the pin, I'm going to hold this for a second. Maybe it's not military doctrine that you ever do it, but people get skilled with things. I imagine you would know, I want to hold this for a little second, because otherwise it's just going to go there and sit and I'm going to miss my target. They're going to hear the thud and then get out of there. Anyhow, they can also be specified to have an instantaneous delay. So as soon as they're released, they go off in the use in booby traps. You can configure them that way. And you see this often when troops are in, say, entrenched positions, perhaps, where they know or recognize or plan to give them up, to allow the enemy to come into them, to fall back out of them. But when they do that, they then booby trap those trenches and those locations. And so in that case, one of these hand grenades configured to have an automatic detonation could be used. They apparently, when they do, the fuse does start to go, they do give an audible pop, which can be an indication to you that there is a grenade close by. It's estimated the effective range of these is somewhere between 30 to 45 metres. 45 metres is a pretty good distance to throw something, particularly if you're wearing gear, you're not on solid ground or in the mud or something like that, or you're trying to throw from an awkward position. So maybe 30 metres perhaps. The radius of the dispersion of the fragments here is 200 metres or 660 feet. So what happens here is that these don't contain flechettes or ball bearings or anything like that, but the outer casing fragments, and it becomes what the shrapnel, which causes the damage. And so that has a range of fragment dispersion of up to 200 metres. About 60% of the grenade body apparently pulverizes during the explosion, and the remaining 30 to 40% of the body splits into 290 high-velocity sharp-edge splinters, each weighing around 1 gram with an initial speed of about 700 meters per second, or 2,300 feet per second. So, yeah, I mean, one of those would just go through you. You won't, one piece. If you got a few of them, you could imagine how lethal they would be. Now, last one here. This is the German Dm51. About 100,000 of these have been given to Ukraine in this conflict. You can actually, with these here, if I just roll up here, they actually have a fragmentation casing on them. That's a jacket. So you can turn this 90 degrees to the right, and you can take off the fragmentation casing, and you're left just with this explosive grenade here. But in the normal operating mode, the jacket is on, and that jacket then fragments as the explosion occurs. These have what's considered to be a lethal range of 10 meters. So if you're within 30 feet of one of these and they go off, that's considered to be the lethal range for these. Now here, again, this is something, this sort of design is iconic, I think, from World War II movies. The RKG-3 anti-tank grenade. So the RKG stands for the Ruchная Кумулятивная Граната, the handheld shaped charge grenade. These, interestingly, the handle of these grenades contains a drogue parachute. So a drogue parachute is a parachute which is used to, actually I've got a picture here I can put up on the screen. Handle and the parachute there. The drogue is used to slow or retard the fall of something. So it's designed for deployment from a rapidly moving object. So this is an anti-tank grenade. As we said before, with an anti-tank grenade, with tanks, usually their weakest position is on the top. So if you can, you want to throw these such that when they explode, they are pointing down on the top of the tank. And so that's what the drogue parachute is for. It's so that when you throw the grenade, instead of it just landing sort of randomly, it tends to, the heavy weight pulls it down, the drogue sits above it and holds it, and so that when it then explodes, it is exploding down onto the top of the tank. Reportedly, the accurate throw ranges for these is about 15 to 25 meters, 50 to 80 feet. The lethality radius is within 2 meters, which is due to concussion and fragmentation. Casualty radius is anywhere within 20 meters. The armor penetration depends on the model. The original RKG-3 used a basic shaped charge with a steel liner. So again, that the explosion goes off, and it then forces the liner of metal to be compressed, and it turns into like a sort of a liquid jet of metal, and that does the damage with that high kinetic energy. The original had a basic shaped charge with a steel liner and could penetrate 125 millimeters, 5 inches against RHA. Now, RHA is a standard rolled homogeneous armor. So when we've been talking about armor penetration, it's usually measured against RHA as a standard. The RKG-3M used a copper-lined shaped charge warhead. That's penetration is increased to 165 millimeters. The RKG-3T variant had an improved copper liner that increased penetration to 170 millimeters. And the RKG-3EM has a larger warhead and can achieve penetration reportedly of 220 millimeters or 8.7 inches. I didn't check that with my dad. That's probably something weird like 8 5/8. You can also get variants now with 3D printed stabilization fins and modified fusing, and these are used on drones. So here you are able to attach one of these anti-tank grenades to a drone, fly the drone out, get above the tank, drop it. I'm sure many of you have seen footage of this. Plastic fins printed on it so that it will spin and head down as you want it to do, and then again fire and explode over the top of the tank, ideally. What was that? Oh, yes, just the last thing here. If you can, it's a little bit difficult to see. Maybe I'll make that a little bit bigger for you. But what this is a patent I found for a thermobaric hand grenade. Now, the flamethrower systems, those TOS-1 systems, which I'll get to in a later episode, those thermobaric weapons are nasty pieces of kit. Now there are plans for thermobaric hand grenades. Anyhow, we'll get back to thermobarics in a moment. So just moving into our last section for this part 1, grenade launchers. So the AGS-17. So this is an old school Soviet auto grenade firing launcher. 29 shots you can load into it, and it's considered to be a heavy infantry support weapon. Now the UAG-40. So this is a Ukrainian tripod-mounted automatic launcher. It has a range of just over 2 kilometers. It will fire all NATO grenade calibers from 40 to 53 millimeter. And it can fire at 400 per hour, just under 1 every 10 seconds. Now, the magazine that's on that there, I don't know how many that contains, but that's, it may not get to 400 in a minute, but that's the rate at which it can fire. So you can imagine, again, this is, for relatively close combat or at 2 kilometers away, trying to suppress your enemy, something like this, as you can see here. Ukrainian soldiers mounted on top of what may be some sort of a military vehicle, may even just be something like a Land Rover that's been mounted on the roof of it there. The RPG-40 grenade launcher. Now this is a Polish unit. It's a handheld 6-shot revolver which fires a NATO 40mm grenade. And then where I think is probably the coolest looking of these, this is the Russian GM94. It's a 3-round pump action grenade launcher. I just feel like this is crying out for some movie to be made using one of these. Just the look of it. It can also fire a thermobaric round. The VGM 93.100 round with a minimum safe distance of only 10 meters. So you don't want to be within 10 meters of that thermobaric round going off. Any closer than that, you're a toast, I imagine. The marketing about the GM40 does go on to say, here is a picture of it, allegedly, with its thermobaric round going off. It is allegedly well suited to close room-to-room fighting. Its simple design and operation allows it to operate in dusty and dirty environments, and even after being immersed in water. So, sounds like it is quite simple in its design. Although we could be a bad morning doing room-to-room fighting with people using these. Anyhow. The last one that in this part 1 of this video of from the ground on up Ukrainian tools in combat in Ukraine, this is the Schmel flamethrower. So that's this device here, which is reportedly causing this type of explosion. Now, if you can see in this explosion, just here on the left at the front and just here at the right on the front, they are men. So for scale, the Schmel is a single shot, man launched flamethrower grenade launcher. The basic rocket is the RPO-A, which has a thermobaric warhead and is designed for attacking soft targets under moderate cover. The RPO-Z is the incendiary warhead, designed to spread fire and ignite targets. There is also a smoke-producing warhead, the Dm51, which is the RPO-D. They have a range of 20 to 100 meters. 20 meters is a long way if you've got to hop, but 20 meters when you're letting something like that off does not seem like a safe operating distance to me. I think I'd rather be using it at the 100-meter range. This is with the upgraded RPO-M. You have a range of 1,700 meters. Now, 1,700 meters feels like a sensible distance to be using one of those, but you can use them at a range of only 20 meters away. Now, we will come back in a later episode to the TOS-1 heavy flamethrowers. So look, that is the end of part 1. In part 2, I'm looking to go through anti-tank weapons, MANPADS, mortars and artillery. Part 3, we'll get into heavy equipment, tanks, infantry fighting vehicles, armoured fighting vehicles, armoured personnel carriers, BMPs, that sort of thing. And then part 4, get our way up off the ground into the air, drones, missiles, air defence and aircraft. Look, I've found some of this stuff to be interesting. I hope if you've watched this that you have too. If you haven't already subscribed to the channel, please subscribe. If this is the first you've seen of the channel, this is kind of a first off of this type. Normally they're a daily update of what's happening in the battlefront. I cover off Ukraine and Africa and wherever things are heating up. Serbia might be next. If you haven't subscribed, please do subscribe. If you already are a subscriber and you're enjoying this channel, please share it with someone that you think would enjoy it as well. I hope you have a great weekend and I will talk to you soon.